Uh, so today we're going to talk about streams, and I think we may actually either right after this or kind of in the near future do a couple more sessions on streams just to build up from kind of the basics to some more complex, closer to the real world examples. But I think this is the first time we've like really talked about streams since ZIO 2.0 was released. I think we did one session like back maybe in January during the development process of ZIO 2. But we thought this was a good time to just go over ZIO 2 streams and talk a little bit about both what's the same and what's different. And so I think one good thing is if you've used streams in ZIO 1, I think to a first approximation, most things you're doing are going to work basically the same in ZIO 2. So like, let's create kind of a simple stream. Maybe we'll say stream is going to be Z stream. Maybe I will repeat something, and I'll just do this console print line. Hello, Zymposium. And then this just this is just going to do it forever, which is fine. So maybe we'll do that, and then we'll take 10, say, and then I could do and then let's run this stream. And so now I actually maybe call this run stream. Yeah, if I don't change the names up on Kit. There we go. Yep. So I'll run this guy.
So we'll get a, because you're printing. Yeah, so we're just going
to I'm printing it here. We'll get 10 times and we'll get the result here. And so there's nothing particularly fancy here, but I think that just the first thing to note about it is like, this is basically the same as what you would do in ZIO 1, with the exception of like slight changes that you're already familiar with if you've just moved from ZIO 1 to ZIO 2. Of like in ZIO 1, this would have been repeat effect versus we said, well, effect is a little bit too kind of historical legacy, repeat ZIO, just say what we're doing. In ZIO 1, this would have had one more layer of nesting. So it would have been like lowercase console print line, and it would be like put store line versus print line. So we have a little bit of the just like quality of life improvements, but otherwise this is essentially exactly the same thing as we would have done in ZIO 1. Mm-hmm. And that's the case for most things that we're doing with streams in terms of like our direct user-facing API for most things. I think the biggest change between ZIO 1 and ZIO 2 is we went from this concept of transducer to pipeline. So if we maybe make a little table for ourselves here. Oops, that was a weird. So in both ZIO 1 and ZIO 2, we have this concept of you could kind of almost call it like a source, or maybe I'll call it beginning, a middle, and an end. And so in ZIO 1, this was a stream. So a stream produces elements, it doesn't consume them. The end for both of these was this. Oops.
I'll do the I'll help out with the fancy indentation in the background.
And then the middle in ZIO 1 was this thing that was called a Z. I think it was just called transducer, not Z. I don't think we had a Z. Maybe we had a Z. But it was a transducer, and here it's a pipeline. And these essentially serve the same purpose in ZIO 1 versus ZIO 2. Of these represent the middle of a data transformation pipeline. So, and yeah, I think Kit is going exactly in the right place. So if we think like we're going to construct this whole pipeline, if we want to, we can describe each part of the pipeline as a value. And so we would like start by having some stream that maybe the stream is like coming from subscribing to some Twitter API or what have you. Then we have a set of transformations that can be described either just using stream operators, or if we want to describe them as their own values as these pipeline or transducer things. And then at the end, we have where they go, which is a sink. And I guess if some of this has this like weird like water analogy, right? Of like the water kind of comes from the stream and it like goes to the sink, I guess. So I think if you're like just kind of using stream operators and you're never like implementing your own, you're just kind of using the existing operators, you're going to find that ZIO2 streams are really very similar. And I think the most significant change you're really going to have, other than just these like renamings, is just if you were using transducer before, you're going to use pipeline now, and operators that you found on transducer before, now you're going to find on pipelines.
We did get a question that maybe is worth addressing very quickly, because we are talking about streams and sinks. And Alexander Novikov asked, doing streams at work, but little understanding, is a sink not always needed? And so then Adrian mentioned that run drain makes a sink. And in fact, it's probably worth just noting that, yeah, you don't necessarily need to use this collector explicitly, these sinks, because these streams come with a lot of run methods on them that sort of will process the stream into some sort of final result, basically translate it into a ZIO of some final result. So run drain, for instance, will just sort of run the stream to completion. So runs until the stream completes. But then there are other ones as well, and that's always returns basically a ZIO of units with whatever the error type is, and the R, because we're just running for the string for its side effects, in this, which we're doing in this case, we're just printing 10 times. We don't care about the unit results that this outputs. But there's also run collect, which gets back a ZIO RE of a chunk of whatever the type is. So if instead this were, just a string, we could then say run collect and then debug here for the final result. And this should, this is because it's repeat ZIO, I need to say ZIO.succeed of that. And that should be fine. So this will now get us back a sort of a ZIO of a chunk of strings. And if we print that out, can we run that real quick? Maybe
there we go.
So there's our chunk of string. So you don't necessarily need to and then there are a bunch of other ones. If you just look at all the run options, you could sort of be more manual about it and run fold and have some state where you process each value. So it's more like a left fold over a list, except it's streaming and asynchronous. And there are a bunch of run methods. So run for each will just let you do a ZIO side effect for each value and then also return a ZIO of units. So yeah, and that we could have done our same thing from before, just by like ZIO debug string, and this would have gotten us something like this. Anywho, a lot of options. So you don't necessarily need to sync explicitly, and probably that's mostly what you want. If you're just sort of at streams 1.0, you're going to somehow make a stream that collects your input, maybe repeatedly calling a remote API, doing something clever like that, and then probably just processing the stream into some ZIO effect using one of these run methods. And then that's behind the scenes going to use a sync, but you don't have to do it manually. So yeah, that's all I just wanted to mention up front.
Yeah, I think it's a really good point and a really good question. And I think you have the right idea that probably if you're like just starting with streams, I would just use streams for until you kind of need something else. Because as you can see, you can start with the stream that's like this source of data. I mean, here it's kind of a source of like printing things, but maybe we can make this just like numbers, right? This is a stream is a source of numbers. And then we can transform it, right? We can like, we can double it. We can filter. And then we can run it, or we can kind of do some terminal thing with it. So we don't need these other data types at all when we get started. And I think probably if you are getting started, this is like the simplest way to get started. But where these other things become useful is where like this is a data transformation step. And I mean, here it's just multiply by 2, so we don't need anything. But if this data transformation step is like decoding JSON, then maybe we'd like to describe that like JSON decoding transformation as its own data type instead of as just being this operator. And that's where these like transducers or pipeline data types become nice, is that we can describe each of these as its own value, and it can actually be like a object that is first class that we can work with, that maybe different components of our application can use. But you can always take something that's just a transformation like this and refactor it into one of these things. So I think if you're just getting started, this is like a great place to get started.
Mhm.
Okay, so I think first piece of good news is just it's pretty consistent with what we were doing before in ZIO1. So to the extent we learned about some of this stuff, we can reuse what we know. And maybe this is a good point. I don't know if you're manning the Discord. Are there any other questions about just if you're kind of using that like basic API of how do I do something in ZIO2 versus ZIO1?
Oh no, we're all good there. Okay. And I'll just do my normal reminder for people to join later, but we generally chat in Discord, so I sent that out to everyone again. So join us there if you have any questions, not in the Zoom chat, which is disabled.
Nice. So what I think we want to work through a little bit today is I think the motivation for this was someone reached out to us and was kind of like, okay, this is great, but what if I need to implement my own operator that I can't just implement in terms of like one of these existing operators? So like I think they were working with sinks here. And we can see, okay, there are a bunch of operations on sinks that do all sorts of different things. But maybe not surprisingly, there are also some things that maybe we'd want that there aren't operators for. So like we can see there's this map error thing, which that's a pretty familiar operator, right? We probably know about. We've maybe used this map error operator on ZIO of it's just going to transform the error type. So a sink, just like other ZIO data types, can fail with an error. Like maybe the sink is supposed to write to a file and it can't write to the file because the file doesn't exist. So maybe it's going to fail with a throwable, that's some kind of file not, folder doesn't exist or not found exception. And maybe we want to transform that error. Maybe we want to transform it into like a domain specific error. So this is here, this is great, but we might want an operator like map error cause. So if we go to ZIO, there's this other operator called map error cause that lets us work with this full cause of failure that has like the tracing information, and if more than one failure occurred or if a die failure occurred, we get to like see all of that and work with it because maybe we want to like log it somewhere or maybe we want to do something else with it. And we can see that at least right now that doesn't exist on this. And so maybe we want to submit our own PR to ZIO to add that, or maybe we're just like, they can catch up in their own time. We want to implement it ourselves, but we'd like to implement that. And we kind of want to know how to do that. And we may be able to do it in terms of some existing sync operators, but let's kind of assume for this that we don't kind of see an existing operator that's going to do quite what we want to do here. So how do we get to the point where we can do that? And what's that kind of telling us about what's going on under the hood with all these stream things?
Could we actually take this one step back really quick? Just to
please.
Maybe transform this into, instead of using this sort of like for each method, which I think might do the same thing as run for each. I'm not entirely sure actually. I think I was thinking of, I think they're basically aliases for each other. So this will just run the stream, running this ZIO effect for each value and turning it into a ZIO. But what if instead of this, so we have this stream basically of now these numbers that are divisible by 3. How would we connect this? So like divisible by 3 stream into, how would we compose this using like a very basic sync? Maybe just to show off how like a sync works. Like what's the, I guess is collect all.
Yeah, so I think collect all is a really simple one. Yeah.
And
so
then
let's
Is it something like that? Is that how that
Yeah.
works?
Yeah, exactly. You can either use run if you want to use kind of the like named operators, or you can use this arrow. Yeah. And you can think of this as kind of nicely visually reflecting what we had up here about this idea of we have a beginning, a middle, and an end. And so we just like take it from one and we send it to the other. And so, yeah, why don't we try running this? Let's see
Oh, let
what
me
we got
just
here.
debug as well at the end. Hello.
Yep.
It seems to be sad.
Let's see. This thing I believe needs a type annotation. Just because this is kind of, it's describing this thing that takes an input. And because it's describing this thing, it takes input as a data type, like it doesn't know itself what input it's supposed to take. So sometimes when you're creating these syncs, you didn't specify like a type parameter here.
Okay.
But now if we run this, we need to take a finite number of values here. So this for a sec. Yeah, so let's, or actually, maybe we can, that's a nice thing we can do with our sync. So I believe there's another, we don't really want to collect all. We want to collect maybe, oops.
Int 0, a 0 byte integer.
What are we doing?
Ta-da! Maybe it is running forever. Is that? That's interesting. I'll do a tap on this guy too. ZIO.debug.
Oh, well, we're not producing any values because these are all ones. We multiply them by 2 to get 2s. We filter them.
So we're never going to get 2 values.
Yeah.
Okay.
So let's maybe remove our filter.
Wait here. We can do that, but let's just do a ZIO and then we'll do random dot next.
Perfect.
In bounded.
Yay! Yay, math.
Yeah, let's try that one.
All right, let's do that.
And I think I've screwed something up. There we go. Okay.
It's missing a parentheses. Okay, let's run that. There we go.
So we've got some number of numbers which we've multiplied by 2, and then filtered whether or not they're divisible by 3. So cool. That looks generally accurate, I think. So we got, I guess, must have got 12 and some other numbers there. Cool. So like, just to make it clear, this is basically identical to in this case, take 10, run, collect. So in this case, you probably just want to do something like this. But if you are describing these ways of collecting streams in a more generic way, ZSync is this optional data type that gives us a lot more flexibility just as the receiver of a string. So it can be nice to abstract over this.
Yeah. And if we want to, we can do the same thing on some of these other steps. So we could say, maybe instead of this map thing being just this little method we call here, maybe we want this to be its own data type. And I think I can do that with a filter too.
So something like this then would probably be equivalent to whatever, map times 2 filter is divisible by 3, take 10 then.
Exactly.
Does that run?
Let's do it. Let's see, what do we have here? Oh, we need one more.
Oh, we have more arrows. More arrows, I failed. I'm trying to do bit munging. Hey, okay, cool.
Yeah.
So yeah, hopefully that makes it a little clearer that these pipeline and sync types are really just, and I could pull this out to sort of like collect 10. These, like, they're reifications of these ideas, which is something that we do in functional programming all the time. Instead of just having things sort of exist implicitly as just operators or explicit, sort of implicit manipulations, we try to turn them into data types. Not just for the heck of it, but because by doing that, we end up we're forced to realize exactly what that concept is and, encode it as a data type. And then we often get sort of interesting combinators that we wouldn't be able to, well, first of all, we get to make it composable as well, right? You don't have to just make one big method that you have to have all these inputs for. Instead, now we can have our sinks be composable, and we can write methods on the sink itself. So that map error type that we were talking about before, obviously the error for collect all in happens to be nothing. But if instead this were like write to file, then that might throw some, IO exceptions, and we might want to translate those into some other data types. So by making these first class values, we now have a type that we can sort of build up compositionally out of smaller pieces and break apart our pipeline, which in the simple case, you would never want to do. This is so simple that we probably just want to use these methods built onto the stream itself. But in more complicated streaming scenarios, it is actually very powerful to have these as first class reified values that we can add, that we can transform. Okay.
Yeah, and this can help you make your code more modular, where like this may not be some simple thing, but maybe some really complex machine learning transformation you're doing. And this way, like you just have a team who's like, your job is implementing this pipeline with the signature, and then, okay, as long as you have it, whatever other team can just take that and slot it in here, and you can move it around to wherever it needs to be in this pipeline you're creating here. Okay, so we've got these things, and for any of them, for the sink or the stream or one of these pipelines, we might need to implement an operator on it. And some of them we may just be able to do in terms of existing operators, right? If I wanted to make this doubler one, I just did it in terms of this existing map operator. But sometimes maybe we need things that aren't just one of the existing operators, and we need to kind of go one level down to how these things are actually implemented. And so if we go back here to like the sync one, what you'll notice here is like the way this map error is implemented is it says, okay, create a sync, and then it says channel map error. And so we might wonder, well, what's this channel thing? And if we go up here, we see that a sync just is a certain kind of channel. And this channel has like 7 type parameters, so it might be a little bit scary. So we might be wondering what the heck is going on here, but that's why we are together, and we will work through it together. But before we look at what exactly these type parameters are, I want to just take a minute and show you that's not just specific to the sync. So if we look at the pipeline is just a channel too. And actually, if we look at a stream, well, maybe I'm not, because there's a lot of stuff in this file. A stream is also just a channel. And so we're getting here to this cool thing in ZIO2 that, oops, let me make this. All of these things, all of these streams, pipelines, sinks, they're actually all just channels under the hood. So it's kind of like if you like have that thing where like, oh, it's the elephant, and everyone sees like a different part of the elephant, and they see a different aspect of it, but like it's all the elephant. Like all of these things are actually this one thing called a channel. And what that means is that there can be a lot of code reuse and unification between these different data types, because they're all under the hood the same thing. And so we can use the same operators on them. And when we make optimizations to that channel, then that actually optimizes all of those things versus each of these things being its own totally separate thing with its own way of doing everything that it does. So let's look a little bit about what this is the elephant. I like that. So let's look a little bit at what this channel is and try to understand it a little bit better, and also like how can it represent these different things, because these like things all seem like pretty different. So how can we have one thing that represents all of them but is also like specific enough for us to actually implement and for us to do all this stuff with?
Could I inject some suspense by bringing us up down one more tangent just because there was a good question that I think
Yeah,
is
please.
also important for understanding this stuff.
Yeah.
So one asked, can we input the same stream to different pipelines? And maybe that would be nice to show off very quickly. That basically these streams, it's important to think of them just as you think of effects. They're just blueprints. So yes, you can input the same stream into different pipelines. So we could do something like, run stream 1 and run stream 2 and share this, and in one sort of filter out values and in the other not filter out values, or let's say collect 10, and then let's actually have the same thing, except we'll have collect 10 and maybe collect 5. But if we run this with collect 10 and collect 5, if we run both of these one after the other, so maybe I'll just do 4 yield and do run stream 2. Run stream 2, run 2, run 1. Can we run that real quick? If on the side spelled everything.
Maybe not.
Okay, now we can do it. I think. No? Oh, no.
Hold on, let me just.
Oh, there we go. Now it's good.
Yep. Nice.
So these are the same, except they're piped into different pipelines. But as we can see, they actually have totally different results, even though the only real difference is that we changed the sync, right? So let me maybe move those comments down so we can see everything at once. Where is my? Yeah, so let's move this below. So basically, these look identical except for the fact that they have different syncs. But if we remember, these are all blueprints. So it's just describing how to create a stream that will generate basically random numbers. At this point, I suppose it's random nums. Random nums. So they're each gonna generate different random numbers because it's just a description. It's not literally the same stream of random numbers. There are ways of doing that, but basically we'd have to memoize the stream or do some kind of broadcasting so that we'll share the actual same generated random numbers and can run them through the same pipelines. So, but you can definitely run the same stream as many times as you like through as many pipelines as you want. It's just important to sort of keep in mind the semantics of these pure streaming descriptions, which are that indeed they are descriptions by default. And you'll have to memoize them explicitly if you want to like share them, or I guess broadcasting would be the terminology if we wanted to actually.
Yeah, I was gonna say, do you want to do that now?
Yeah. I think in order to do that, we might need to change it around a little bit, right? Because we will need to like accept in the stream that has been shared, right?
So I think we can just do broadcast, and let's say we want to broadcast 2 streams, and we have this parameter for how far we want to let one stream get behind the other, which I don't think really matters here. So maybe I'll just set it to 16. And then I think we can flat map that, and that's going to give us a chunk of streams. And so then I think we could do, let's kind of say val subscriber 1 is going to take the first of these 2 streams we're creating and send it to, I guess we want to do the doubler, do we want to do the collect, I don't know, I guess that probably doesn't matter, we do the collect 5 or the collect 10. So then we'll have another one that is going to do, oops.
Oh, my bad.
No, the collect 10. And so these are each going to be ZIOs here. And then, yeah, I think we can just run those 2. Let's kind of check our signature here if I can get some, oops, there we go. Yeah, so we got these 2 sets of chunks, so we can probably debug that. Okay, so let's try running that, see if this does what we want.
Cool. So now we can see that one stream is just sort of double the length, but has the same beginning values. So now we are sharing the results of just a single random nums here. Now, it is also possible, though, to sort of do, I think, maybe the most it's a little, to me, I don't know if everyone agrees, but like it's a bit awkward that, I mean, it's definitely useful at times to get back to a low level like chunk of these different streams. We're basically splitting this into 2 different streams, and they each have their own, they could be shared amongst workers and all that. But sometimes you kind of just want to like dynamically broadcast, I guess, right? And isn't there's another way.
There's a broadcast dynamic, yeah.
Yeah, and that also returns a ZIO effect, right? So let me see if I can do a second example below. Maybe that'll run string 2. So like if we have a for comprehension, shared might be random nums dot broadcast dynamic. Need that maximum lag again, and then we could basically do something that might feel a little more natural, which is just shared, right? We could just actually use it, and this is going to automatically take care of that for us, I believe. Maybe there's some details here that I'm going to screw up, but C1, C2 yields C1, C2. And then let's call run stream 2. Do you think that'll work, or is there maybe some race condition here?
We may get slightly different ones based on when they subscribe, but yeah, no, I mean, that's working totally fine for this.
Oh, okay, cool. All right,
Yeah.
so run stream, and that's the second version. Okay, cool. So yeah, both work if you don't feel like, explicitly pre-optimize or pre-deciding how many actual streams you want to broadcast out to, and just like want to treat it like this sort of almost memoized variant, shared variant, where like you're never creating a second random number stream, and you're sharing the values across multiple pipelines. You could just do broadcast dynamic, which is, yeah, generally, if you make streams from hubs, if you've seen some previous sessions that we've done on Z hubs, it kind of has this behavior dynamic, like automatically, and it tends to work great for like pub sub models. So it's quite flexible, and you could do a lot of things at a lot of different layers. I think this session is generally more low level than just like the highest of how to just use streams in the simplest, most straightforward context. It's more like how do we dive in and understand the innards and write custom functions. But yeah, I just wanted to go over that basic.
Yeah, no, it's super helpful.
Cool.
Okay, any other questions here?
I think we're good. Oh, there was one question, was just you have 5 elements in the first chunk and 10 in the second chunk. And that's just because, that is correct. That's just because the first, well, actually.
No, I think we have?
Oh, maybe we
had
did
collect 10 at one point.
Second one, now that I think about it. Can we run that one more time? Maybe I didn't save.
Sure.
There might be a detail there. Because yeah, we didn't actually have different chunks. Okay, so yeah, that's kind of what I was maybe seeing, is that because we're running sequentially, it might not exactly do something like that. So I might need to actually make these sort of like stream 1, right, and stream 2, and then do something like S1 zip par S2 debug results. Is that maybe can we try that? Because we're running them sequentially, it might not have subscribed at the right time. Maybe there's still a minor race condition here. So they're off by
so you can see.
This is sort of a detail about it, but like because there's the zip par, maybe this one's going to subscribe a moment before, get the first random number, just because it's sort of, there is no delay for how it's creating these random numbers. It's creating them immediately once you start subscribing. So when the second stream subscribes dynamically to random nums, well, it already started broadcasting out the first value to the first one. So there's going to be a slight race condition here, but it's not really, I don't know if it matters that much in practice, because you probably aren't just building a shared stream and doing that. But yeah, maybe we want to discuss that.
Yeah, so typically when you actually do this variant, these things are like coming over the wire, say. And so you're just like picking up, right? I mean, let's say you're like subscribing to stock price events, right? And you're just like picking up stock price events whenever you subscribe, and you kind of know there've been previous stock price events before you subscribe, but you just kind of, you pick up the subscription and you just kind of see the events from there.
Yeah, can you run it one more time? I just added a delay of 300 milliseconds to a random nums ZIO effect, and so now hopefully I think they'd be shared, but I maybe not. But we'll see. It's going to also take a little longer because it's going to try a bunch of random numbers that are divisible by 3. Maybe I should have made that shorter. Actually, there we go. So now they're all shared.
Yeah. So yeah,
there was like just because it literally took no time and was able to broadcast immediately. zipar had the slightest of race conditions, but in most real world scenarios, it doesn't matter. And there are other ways you could deal with that for like tests, but yeah, it's probably not even worth getting into that level of confusion. This way generally works really quite nicely. Okay. Anyway, thanks for that tangent, and now we can move into the implementation.
Yeah. Okay, so I think we're just starting to talk about this concept of these channels.
Yeah.
And so we have this thing called a Z channel, and it's actually got 7 type parameters. So they're a lot, but we will work through them together. Okay, so we got these 7 type parameters, and I think the first one in channels we call ENV for environment, but if we're in like the ZIO world, we could also think about that as R. This is the environment that the channel needs to run. So if we're used to working with like ZIO, or in ZIO1, if we had been used to working with like zmanaged, or if you've ever worked with like zQuery or like the HTTP data type and like ZHTTP, like all of these data types have some kind of environment type parameter, because we want to have some way of describing the dependencies that this channel has, right? Of maybe in ZIO2, this channel needs a scope. Maybe it needs something else to kind of do what it's doing. So I think that one is relatively straightforward if we're already in the ZIO world. Then we have these 3 type parameters that are kind of mirror images of each other. We've got an error type, an element type, and a done type. And we've got input versions, and we've got output versions. And so a little bit of how we can think of a channel is, it's almost like if we had like a low level, like a asynchronous file channel or something like that. It's this thing that we can send inputs to, and that we can get outputs out of. So almost like if we were looking at like one of those like circuit board things, like this is like a circuit that like if it takes some things in, it sends some things out. And what this is saying is this channel has 3 input channels and it has 3 output channels. And so one of them I think is relatively straightforward, it's this error one. And so if we're used to working with ZIO, I think we're pretty used to having some error type. And so the output type here, this out error, this represents the error that the channel could fail with. So maybe this channel is maybe it needs to read some files as part of doing this transformation, and maybe it can't read the files. So maybe it's going to fail with an error, or maybe there's something that's corrupt about the data that gets sent into it. And so it wants to fail for an error for that reason. So one thing that a channel can do is it can fail with an error. Another thing a channel can do is it can ultimately be done with some type of summary value that says, okay, I'm complete, and here is my final value. And then the other thing that these channels can do that makes them more powerful and able to express all this stuff is that they can emit an element without being done. So this channel could say, well, hey, I've got some intermediate output of whatever, that's an int, that's a string, that's some JSON, and it can emit 0 or more values of this. And so the contract of a channel is that it's going to emit 0 or more values of type out elem. And then if it finishes at all, it is going to finish with exactly 1, either out error or out done. And similarly, the channel is going to have to accept 0 or more values of type in elem, and potentially accept exactly 1 input of either in done or in error. So we can think of this as like a circuit that like has these three inputs of like, you can send it an error, you can send it a done, you can send it an element, and it's potentially going to send out itself some different errors, elements, or done values. And so I think sometimes another way of you can think about this, if like you're familiar with like reactive streams, is you could think of this as almost like the functional version of like reactive streams, right? Where you have this protocol of like this thing can like accept these inputs with this protocol and it'll have these outputs with this protocol. And so what is really interesting about this is that we can use this to describe all of these different data types. So like, let's think about what a Z stream is in this world. And maybe I'm just gonna. So does anyone have an idea of how we would fill any of these in for a Z stream?
Well, what are the, I guess we should start with the input parameters, right? For ZStream itself, we have, right, in environments, error, and output.
Yeah, or sometimes I think we call it REA, but yeah, maybe.
Yeah, let's do REA. Cool.
Yeah.
Well, let's. I won't try to compete with our chat in case anyone has any guesses.
Yeah.
But no one said anything yet. Here, I'll try to.
How about someone guess one of these type parameters?
There's
at least one that's very easy.
Yay, R, right?
Yeah, this first one is R, exactly.
Bing, bing, because yeah, R is just our envi run and cool. All right, and so where do we put our E's and A's? Let's try E next. Where should the E go? Where does the E go, team? There is no ego. Okay, out air and out LM. So those are the guesses that it goes. Ooh, whoa, whoa.
Sorry, hold on. Let me
no, it's all right.
I screwed up. Yeah, so I think the out error is pretty straightforward. So we can make that the E.
Out error. And the guess here, I think, was out LM.
Yeah, and that's basically right. So it is going to have the A here for the out LM. And the only change we're going to add here is we're actually going to make this a chunk of A's. Because for efficiency, we want to build in this idea that we don't necessarily just emit one value, but we emit a whole chunk of value so that we can process one chunk at a time and we can amortize the overhead of doing these streams when we want to have high performance applications. So we'll use a chunk here instead of actually the A, but conceptually that's 100% right. Okay, so how about we still have 3 question marks to fill in? Anyone have an idea about these?
I'll look at the chat. See what we have. What do we have to fill in? The input error, input element, input done, and out done. So any guesses on these fellas? Oh, boom, 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 boom.
Nice.
Outdone can be unit, is one guess there.
Yeah, that's totally right. And you could think about that if you go back to like the earlier, like the ZIO1 encoding of streams, was we said the stream is going to emit values and eventually it's either going to fail with an error or it's just going to say I'm done. It doesn't have any more information to say about like, assuming it didn't fail an error, it's done. I'm finished. Doesn't have any more information about that. It just says I'm finished. And so we could use unit, or if we wanted to, we could use any here, but that's 100% right.
Cool. And so all that remains is inputs, the input types. So what should go there? What input do we feed into a Z string?
Well, does a stream need any input?
Input LM nothing. So yeah, I guess the guesses there would be maybe no, nothing, perhaps, except I guess because these are contravariant, maybe that would be indeed any, but yeah, what would that be?
Yeah, so it would actually be any, and a way to think about that is you can kind of analogize it with the environment type, where if we've got something that doesn't require any services, then you can run it with no services. And so we actually use any because you say like, look, you can give me anything you want. You give me the unit here. I don't need anything specific to run. If we use nothing here, that would actually be saying I can only be run if you give me a value that doesn't exist. So then we wouldn't be able to run the channel at all. But this says this is a channel that doesn't need any input.
Yeah, the riddle of kind of makes it more into a strange riddle or something. I will do whatever you want as long as you give me something impossible to create.
Yeah. And so we can go and we can like check ourselves here. Oops, it's Z string. And so we see we've got exactly that. Here it's any instead of unit, but that's basically the same thing. So that's exactly right. So how about this sync type? Let me see if I can quickly grab this without you looking at all the types. So this Z sync thing. Yeah, I gotta watch out for Copilot here. May also steal my thunder. So it's got an environment type that the sync can fail with, or sorry, that it needs. It's got an error type it can fail with. It's got the type of input the sync accepts. And then the sync is going to produce a summary value, and it's going to potentially produce some leftovers. And so these leftovers would be like if we're like parsing something and we've parsed one thing and like we're done parsing it, but like we got this chunk that has some other stuff that like is not part of the thing that we're parsing yet, we would kind of shove that thing back and we would let someone else deal with the next one. So that's what that leftovers type represents. So does anyone have some ideas of how we might start filling this in?
Just gonna see some typing, so I'll give it a minute. Feel free to call out any guesses. So definitely R. Yeah, R.
Yeah, I know. If you want to get like easy credit for these, like the easiest thing to do is call like the R type first. You just like you're done for this exercise. Okay.
There's still some typing. Type. It's a race. Everyone's typing.
Race condition, yeah.
So the error type now is thought to be the input error type, which I guess would make sense now, as this is, I think that makes sense to me. What is it asking the judge?
So I think two things you might think about here is one is we said is notice this has the plus. So this is an error that's coming out versus an error that's going in. And the other thing is maybe just what we talked about in terms of words, we said this was the error that the sync could fail with. So like if the sync is supposed to write to a file, it could fail with this error of the file doesn't exist. So this is actually this out error type. And the in error type here is actually nothing, because syncs don't handle errors. They just handle values. Typical stream implementations, if you run a stream with a sync and the stream fails, it'll just pass through that original error. The sync doesn't know how to handle that error. The sync just knows how to handle the inputs.
And it's not any, but actually nothing this time.
It's actually nothing this time, yeah, because it's kind of the contract is like, I don't know how to handle that.
Okay.
Because if it got some error that wasn't this, then it wouldn't know how to convert it to this.
Okay, so we're not even calling it able to call it with any errors. Okay, so and then I guess so there was definitely some answers, which is that the leftovers would be this, and then the Z would be here.
Yep, and that's 100% right. And the only slight change to that is we're gonna chunkify this again.
Chunkification.
Okay, and we got two left.
Cool, and then let me see.
I think we still got the
Oh yeah,
in.
oh yeah.
Figure out
The
what
in was.
is.
I think the in was clearly. Well, maybe not clearly, but was guessed as the in element.
Yeah, exactly.
And yeah, and in done. I don't know if anyone went for in done. Any last guesses on in done? So that would mean. Yeah, I don't know. I don't know. Maybe any again. Maybe nothing.
Yeah.
Maybe
Yeah, I think this can just be any here because we just need something to tell us that it's done. We're not going to do anything with it. We're just going to know, okay, our stream is done. We can finish up our processing and produce our results.
Sure. So what real quick, what is so the difference between the any and the nothing, right? It seems they're both in that contravariant input type. Like why any for how is any for Z stream okay, but not for Z sync?
So any for the stream just means that the stream isn't even going to use these types at all. So we can just throw them away. And so we can just accept anything here. But the reason we need nothing here is we ultimately, like, if this thing fails, then we should fail ourselves. So if this thing could take in any error, then we couldn't honor this contract. We couldn't honor that. We couldn't promise that we're going to produce an E, because if you failed with an int, then we would have to fail with an int. So in this case, the responsibility kind of gets pushed to the caller of basically operators that work with these syncs have to like take that possibility of an error and have to pass it through separately. And there's an operator for that.
I see. So if they fail, they're not going to pass their failure to the sync, essentially.
Right. They're just gonna kind of exactly just refail with that.
And with the Z stream, no one is even calling the input of a Z stream necessarily. They're just using this, they're generating Z channels that produce outputs, but they're not going to feed input into a Z stream. So fine, accept anything, because that's just not how it's going to be used.
We'll just throw it away. Yeah.
Okay. So it needs to, so Z sync needs to constrain its input interface because it's actually used as an input, whereas Z stream, you're not going to use that as an input. So whatever.
Exactly.
Okay.
Exactly. Yep. And then we can do the same thing for the pipeline here.
How many type parameters VA? All right, less.
We got 4, yeah. So we're going downhill here.
All right. Whew.
All right.
Okay,
Who wants to do one of these?
Put in the R. I want the points for R.
Yeah.
Or env, I guess, this time.
Yeah. Okay.
And then, yeah, so where would Saha? Okay, yeah. Alexander also gets claim for the R. Okay, we definitely have some people guessing. So this is a pipeline that we're going to be feeding in input elements, getting out output from, and I guess, yeah, I definitely have some theories, but I'll allow the typers to type. So error is output error this time. Yeah, we can see it's covariant, so we know we can assume it's that output error, though I don't think we've really used the input error yet. So I am wondering when that's going to show up, but there was a guess that that's output error. So is that correct?
Yeah, that's the output error. That's right.
Okay. Out error. All right. What have we else we got? Okay. Oh, a full guess. So a chunk of input and a chunk of output for the in elements and out elements.
Yeah.
Chunk in, chunk out, and then any for the output. But I think we kind of used unit before, so maybe it's still unit, though any.
Yeah, I think we can use either one. I think in the actual one it's any, but maybe I'll use unit here just for consistency with the previous one. Yep. Okay.
Cool. And let's see. Nothing was guessed for out. Wait, what is that place? Nothing for outdone. Though I might assume that that's also any, but someone guessed I think nothing. So let's see if that's correct.
Yeah, so I think this is any, just like for the sync. So it can signal it's done. We're not going to do anything with it other than kind of know that it's done.
Okay, so it's sort of, maybe for consistency, we should make these unit, right? Because it's kind of, or any, either one. Yeah. It's a little weird. So there is this, yeah, maybe we can make them any if that's what it's actually. So there's this distinction between, and it's kind of weird, but when any is used in a covariant type as an output, any is kind of like maybe a more flexible version of unit, theoretically. because we're able to signal that like it's just a dummy value. Like they're both, if you think about it, any and unit really don't contain any information. You can't, as long as you don't use like reflection or unsafe Java things, you can't really know anything about any. It could be literally any type, so you can't make any assumptions about it. Whereas unit is so simple that it doesn't really provide you anything. So they both, when given an output, kind of serve the same purpose. Any tends to be slightly more forgiving in type signatures, because if you need to provide a function that returns units, sometimes depending on your compiler settings, you have to make sure that you actually are putting a unit in there, because if your function returns like an int, then you have to explicitly transform it into a function that returns unit. Whereas int is any, so that's okay. It just makes it slightly more flexible. So we tend to just try to use any instead of unit inside of ZIO libraries, where previously, maybe in general, people use unit. But when any is used as a covariant type, it's basically, contravariant type as an input, it's very different. And it's saying that, it's the top of that contravariant hierarchy. It's saying, well, or it's the bottom of it, I don't know. It's saying like, you can give us anything because we're not going to try to access it at all. So anyway, slightly different uses of any when it's an output. This is sort of used as just a dummy value that's signaling that we're done. And when it's as an input, it's saying that like we have no constraints on this input type. Anyway,
yeah,
probably didn't make a lot of sense. It's tricky stuff. So what's that last parameter that we have? I don't know if anyone's guessed that yet. Let me see. Oh, there's been a guess of nothing.
Yeah, and that's exactly right. And it's kind of the same reasoning as the sync of this thing produces errors. It doesn't know how to handle errors, and so it's got to say like, hey, I don't take those types of inputs. Right? I don't take any errors here. Like you give me inputs, and I'll do something with them. I don't know how to handle errors, so don't even try sending them to me.
Mm-hmm.
And so I think one of the things that's kind of interesting when you like look at this is like, I think all of these are like logical here, but you can also, I think, see, and I think Kit was even getting at this a little bit of like, you can imagine there are other combinations of these that aren't just represented by these three. And that's 100% right. And that's a little bit of like the power of these channels of, I think these three data types are particularly useful. And so those are the ones that ZIO Streams provides. But you could imagine maybe you want some type that knows just how to handle stream errors and how to do something with them. And we could write some data type that does that. And it would also be a channel. And so it would just already automatically compose with everything that we're doing.
So one thing I noticed is that the fact that we don't ever really have an E, it's either any or nothing for the in error. Are there cases where that is something specific, or is it useful enough just to have the distinction between any and nothing?
So I think typically, at least so far, when people have used that, they've done it at the channel level.
Okay.
That's where like you could implement like your own like data type that was like the stream error handler or something. At least what we found so far in the development process was that like at one point we had sync actually have another type parameter. It had like an in error type parameter, and
Okay.
it was just kind of, it was one more type parameter. It made the type inference a little bit worse, so we took it out and we did this nothing thing. But you could imagine having a version of a sync that knew how to handle errors as well, and maybe for whatever you're doing, that's useful. Mm-hmm. But here's kind of an interesting one along these lines.
Oh no!
I got to make sure that this thing doesn't screw me up here or give away my. So.
Give it away. Yeah, should we give Copilot a chance?
I'm worried Copilot's going to be too good. So what would we do for this?
I'd be impressed. How could it really know? I'm gonna test it down below or above. I'm gonna hide. Don't scroll up.
Okay. Meanwhile, anyone want to guess on these?
Oh, sorry.
Oh, careful.
Okay, one sec. Do. I need to know if Copilot is smarter than me.
Anyone got any guesses for these?
Okay, I copied Copilot's guess, ready for public guesses.
Uh,
Let me see. Sorry. Z channel R. So yeah, haha, the R in with the R.
yeah,
Like,
yeah. All right, good call, good call. And we got anyone else?
so yeah, we have a full one. R any E. Okay, we got a few guesses. It looks like everyone has pretty
Okay.
much R any. So R
Okay.
any. And then
Yeah.
the differences between okay. We've got a few differences in the end. One was E chunk A, and another one was, and then another two were E A any.
Okay. So this is good. So that's some interesting things. So so E is right. So to think about this, let's think about what we said the contract was for these out types. So we said we're going to emit 0 or more values of type out elem, and we're going to, if we finish it all, right, we might never finish, but if we finish, we're going to finish with exactly one value that's either an out error or an out done.
Yeah.
So if you go back to that, like what would we say is the guarantee with respect to these, the E and the A and ZIO?
So yeah, I mean, with ZIO, we have to return either a single failure or a single result. So that sort of that out elem channel, I'm guessing, kind of has to be nothing, right? We can't output more than once. That would break the contract of ZIO. And then we're just going to get there. Hey, look at that. All right, let's re-implement ZIO. Let's go.
Yeah. So, and I mean, I think this is where like some of this is maybe geeking out, but I feel like this is like a little bit of like the joy of like Zymposium of like, at least for me, it's really cool to see like the underlying like similarities between things. You know, you're kind of seeing like how things are like the same like atoms, and you put the atoms together in different ways, and you it's
It failed.
yay, there's still hope for humans.
We still have a job for another year.
Yeah, at least a little while. But you can kind of see like how like you have these same building blocks and you put them together in different ways, and you get these things that maybe on the surface look very different. And in a way, like this starts to get to like pretty fundamental differences between like ZIO and these streaming data types, because you look at ZIO and what this very explicitly says is this doesn't produce any intermediate outputs, and eventually it either fails with an error or it gives you a value. And that's kind of what we say about like ZIO, right? Of like, I can fork this fiber and it's going to do whatever it's going to do. But while it's running, I mean, I can interrupt it. I can kind of do some like diagnostics on it. But while it's running, it doesn't have anything for me. It's just running, right? It's like you hire some employee and they say like, okay, great, I'm going to do this thing. Leave me alone for the next 3 months. I'll come back to you with a report. And then eventually it's going to come back to you with the report, or it's going to fail. Versus the like defining nature of the stream or this channel is that it also has this ability to produce this intermediate output to give you like these like updates as it goes. And that's what really differentiates like ZIO from these streaming data types. And this type signature really makes that super clear.
Cool. We've subsumption complete. Yes.
And then I think a fun like exercise, if you want to kind of try to do it yourself, is to like think about how you could use this to describe other things. Like if you wanted to say like, what is an actor in terms of a channel, or like what is a typed actor in terms of a channel? Like what would those things look like? And I think you'll find like this becomes a pretty powerful way to like think about things, because it's like it's very general in a way, right? I mean, we have this environment type, which we've said like why that's valuable. We have this ability to kind of terminate with either success or failure. I think we can intuitively understand why the concept of success or failure is valuable. We have this ability to do intermediate outputs, and then we also have this ability to have inputs and outputs. And so it ends up being like this very general notion of computation in a way that you can use to express a lot of different things.
Well, good stuff. Just a bit of a time check. I mean, we
Yeah.
are at an hour. I don't know if we want to put a pause and then pick it up next week with some more stuff. Like where would we want to go next? I mean, we spent some time investigating this from a type level, which is definitely super
Yeah.
useful. Should we dive next
Yeah.
into the sort of
I think that's right. I think maybe next time we can go to a little more of an implementation level, and I think we can kind of pick up where we stepped away from a little bit of, I think we were like looking at that map error type, and we see, okay, the sink is a channel. So here, if we wanted to implement the map error for the sink, it was just map error for the channel. And so we can basically go to the channel.
Mhm.
And it's got lots of data types, and we can use those to implement other operators that we want to, or we can implement them on channels. So like channel has a map error and a map error cause. So I think in this case, it's going to be pretty easy for us to like implement map error cause on the sink, because we'll just delegate to this thing. And that's where we see a little bit of that payoff of what we talked about, that like all of these things are channels under the hood. And so if we have the operator on channel, we can use it for all these different data types. But I think next time maybe we can also go like one level deeper and see how we would like to fancier things with channels, where there's not just kind of a built-in operator, but where we want to do something that maybe doesn't just transform stream elements, but maybe aggregates them or drops them or does more complex things with them. But I think you probably have the right idea that that is a great topic for next time.
Awesome. Yeah. Well, thank you, Adam, for walking us through that and subsuming all things into one data type. That should simplify a lot. But yeah, and also thank you to Adrian for
thanks for the great idea for this.
About, channels. We'll continue with this next time with an actual like code implementation. And hopefully that was worthwhile on a few different levels. So yeah, if anyone has other requests, just send them out. Definitely go, if you haven't yet, to scholaschool.com or whatever, scala.school rather, not scholaschool.com. I post that in the chat, and if you want notifications for these things, sign up there, and feel free to go and request any topics. There's a link all the way at the bottom of the page for requesting a topic, which will take you to a GitHub repository. It'll open an issue for you, so you can just ask us whatever you want us to talk about, and we'll probably talk about it, because only Adrian has asked so far for that. So
and there's always a new week, and there's only so many ZIO libraries. So
it's
yeah,
a
we're
deep
all
channel of time we have ahead of us, and I think the out, or maybe is it the in LM? I'm not sure. Anyway, but yeah, we should probably head. But yeah, thank you all, and talk to you around.